Hello viewers, in today's lecture we are going to take up some problems which are based on Bayes theorem. Bayes theorem is an important theorem in the theory of probability. So let us take the problem. So the problem says a bag contains 3 red and 7 black balls, right? And 2 balls are selected at random one by one without replacement. Now if the second selected ball happens to be red, what is the probability that the first selected ball is also red, right? So here let us assume that E1 is the event if the first ball is red, right? So the first ball drawn is red, right? Now let us consider the event E2, that the first ball is black, right? The first ball drawn is black, right? So here the bag contains 3 red and 7 black balls, and we have to draw 2 balls at random one by one without replacement, right? So here we have assumed that E1 represents the event if the first ball drawn is red, and E2 represent the event that the first ball drawn is black. Clear? Now let us assume the event A as the second ball, right? The second ball is red. The second ball is red, right? So here we have to find the probability that the first selected ball is also red. Now here we have to find that the first selected ball is also red, so it means we have to find the probability P E1 by A, right? So we have to find the conditional probability of the event E1 when A has already happened. It means we have already got the second ball as red. If the second selected ball happens to be red, it means this event has already happened, and we have to find the probability that the first selected ball is also red, and E1 represents the first ball drawn is red, right? So if we apply Bayes theorem, then P E1 by A can be written as P E1 multiplied by P A by E1 divided by the same factor will appear here, P E1 times P A by E1 plus P E2 times P A by E2, right? So here the conditional probabilities A by E1 and A by E2 are given, right? So what does it mean? The probability, the conditional probability of the event A when E1 has already happened. It means the probability of the second ball is red when in the first draw we have already drawn a red ball, right? So what is P A by E1? So the first ball is red, so we have 3 red balls, so it means when in the first draw we have already drawn a red ball, so the total number of red balls are now 2, and the total number of balls are here 9, right? Because in the second draw uh, the total number of balls will be 9, right? Okay, so here the total number of balls are 10. Clear? Similarly, the conditional probability of event A when E2 has already happened. So PA by E2 is the probability of getting the second ball red when in the first draw the ball drawn is black, right? So here we'll have 3 by 9, right? Okay, now what is PE1? PE1 is the probability of drawing a red ball, right? In the first draw the probability of drawing a red ball, so this is simply 3 by 10, and PE2 is the probability of getting a black ball in the first draw. So we have 7, the total number of black balls are 7, so we have 7 by 10, right? Now by Bayes theorem we have this formula, so we have to substitute the values, these 4 values in this formula. So we'll get for PE1 we have 3 by 10 multiplied PA by E1 is 2 by 9, and in the denominator we have 3 by 10 times 2 by 9 plus for PE2 we have 7 over 10 times PA by E2 is 3 by 9, right? Now we have to solve this expression. So this is 6 by 90 divided by 6 by 90 plus 7 3s are 21 divided by 90. So this is 6 by 90 divided by 6 plus 21 divided by 90, and this is equal to 6 by 90 divided by 27 by 90, right? So 90 and 90 get cancelled, so we have 6 by 27 which can be written as 3 2s are 3 9s are, right? So this is 2 by 9. So the required probability that the first selected ball is also red is 2 by 9, right? Now let us consider the second problem. So here bag 1 contains 3 red and 4 black balls, right? So suppose this is the bag 1, this is bag 1 and it contains 3 red balls and 4 black balls, right? And bag 2 contains 4 red and 5 black balls. So this is bag 2 and it contains 4 red and 5 black balls. Clear? Now one ball is transferred from bag 1 to bag 2, right? So we have to transfer one ball from bag 1 to bag 2. Now the transferred ball may be red or it may be black. Clear? So one ball is to be transferred from bag 1 to bag 2. So the transferred ball may be red or may be black, and then a ball is drawn from bag 2. Now we have to draw a ball from bag 2. Now the ball so drawn is found to be red. Now the ball which is drawn from bag 2 when one ball is transferred from bag 1 to bag 2 and then a ball is drawn from bag 2 and it is found to be red. So here we get a red ball. Clear? So now we have to find the probability that the transferred ball is black, right? So now here we will assume the events, and suppose E1 is the event that the ball which is transferred from bag 1 to bag 2 is red, right? So E1 is the event when red ball is transferred from bag 1 to bag 2. Clear? Now let us consider the event E2, and E2 is the event if the transferred ball is of black color. So E2 is the event if black ball is transferred from bag 1 to bag 2. Clear? And now let us assume the event A, which is the event that the ball drawn from bag 2 is red in color, right? Red in color. So this event, when either a red ball is transferred or a black ball is transferred, then we have to draw a ball from bag 2 and the ball so drawn is a red ball. So this is event A. Now we have to find the probability that the transferred ball is black. So it means we have to find the probability that the transferred ball is black. So we have to find the conditional probability of event E2 when A has happened. So by Bayes theorem we can write we can write PE2 by A is equal to PE2 times PA by E2 divided by PE2 times PA by E2 plus PE1 times PA by E1, right? A by E1. Clear? Now PE1 is the probability of transferring a red ball from bag 1 to bag 2. So this is simply 3, because here we have 3 red balls and the total number of balls are 7. So we have PE1 is 3 by 7, and PE2 is the probability of transferring a black ball from bag 1 to bag 2. So here the number of black balls are 4. So we have 4 by 7. Clear? Now the conditional probability of the event A when E1 has already happened, it means when the probability of the drawing a red ball from bag 2 when E1 has happened, it means a red ball has been transferred from bag 1 to 2. So now the number of red balls in bag 2 are 5, right? And the total number of balls in bag 2 is 10, right? So we have 5 by 10, which is half. And PA by E2 means we have to find the probability of drawing a red ball from bag 2 when a black ball has been transferred from bag 1 to bag 2. So when black ball is transferred from bag 1 to bag 2, the total number of black balls in bag 2 are 6, right? So 6 plus 4, we have total number of balls 10, and the number of red balls remains the same, that is 4. Clear? So we have 4 by 10, which is 2 by 5. Now substituting these 4 values in this formula, we have 4 by 7 multiplied 4 by 10 divided by 4 by 7 times 4 by 10 plus PE1 is 3 by 7 times 5 by 10, right? So now simplifying it, so we have 16 over 70, and this is 16 over 70 plus 15 divided by 70. Now this is 16 divided by 70, and this is 16 plus 5, 15, that is 31 divided by 70, and 70 and 70 get cancelled, so we have 16 over 31, right? So the probability that the transferred ball is black, when the ball drawn from bag 2 is red in color is 16 over 31.